Okay, so let's try to understand how to fetch a new template for dynamic mesh motion type of libraries. Okay, so for that what we're going to do, we try to construct a new wave motions, okay, inside this dynamic inkjet fv mesh library. So whatever is available, we try to remove that part and try to code something like this way. So three different wave type we want to include. One is linear wave, second order stroke wave, and the third order wave. Okay, and the equation is here, and n eta or is nothing but the surface elevation of a deep water wave. Okay, so at the bottom, let's say we want to generate some class of the wave. So how the elevation of that bottom water wave is look like. Okay, and the x is the horizontal coordinate, t is the time, a is the first order wave amplitude, k is angular wave number, it's nothing but 2 pi lambda, and lambda being the wavelength, and omega angular frequency 2 pi by tau, tau is the period. Okay, so that is how we quickly try to code this. And before we try to modify, first we try to generate a template for that. Okay, so important is how to generate this template and how to resolve the dependency. If we try to understand that part, then we are set with the code development. Okay, so for that, what we supposed to do, we first try to modify this particular functions. Okay, so let's try to look at that, how to do that. Okay, so for that, what we can do, we try to add up the first library and then modified it in terms of template. Okay, so let's try to go to our area. Okay, and what we want some type of the, let's say, wave dynamic wave fv mesh. Okay, so that is the name, let's say, we try to give. Okay, so let's say create 004 dynamic, let's say, wave fv mesh. Okay, so that is the name we want to give to our new library. Okay, and now we want to first add up the basic code. So let's go to the our regular install area, src. Okay, in that we have a dynamic fv mesh. Inside the dynamic fv mesh, we have this dynamic ink jet fv mesh. Okay, so let's copy this both files from this area to our area here. Along with that, what's required, we require the make folder. Okay, so let's construct the make folder, and inside the make folder we required the supporting options file. So let's copy from this area. Okay, let me close everything. So copy both this file. Okay, now let's open this and we try to resolve the dependency. So here, before we go towards that, let's try to give a similar name what we have as a directory here. Rename this as a C and H file. Okay, fine. Okay, now here we require only one name. All these things, let's delete that. Make sure we are transferring into the user libbin. Okay, and library name also, let's same name what we have here. Okay, I don't want inkjet, I want supposed to be, this is the name. Okay, okay, I don't want ink in it. Okay, let's say dynamic dynamic wave FV mesh, that is I think perfect. So let me change here as well. So in ink not required, so dynamic wave FV mesh, that is better. Okay, so let me close this also and also rename our folder accordingly. Okay, FV mesh, fine. So we are set with this. Now let's open. Okay, and also try to modify the internal entry. Okay, so in case of this we required dynamic wave FV mesh in this document, so everywhere we try to change that same line in the C file as well. Okay, so everywhere first we change. Okay, now let's try to compile and make sure our template is ready. OF 3.0x all, then wmac libso. So dynamic fvmesh.c file is no such a file or directory. That means that file is not reachable. That is correct. So how to resolve? You have two ways. Either first go to the application area, okay, and solver. We know that which solver normally work with the dynamic mesh motion, so go to that area. Let's say pimple dynamic form, make its options. If you look at, try to check what different things we have here. Along with that, open our file as well, option file. Okay, so dynamic mesh is included, fine. Okay, what else is missing? Just check dynamic FV mesh, and both these things and the meshing tool, these things is required. Okay, so let's check that many options we have here or not. Meshing tool we have, fine. Then dynamic FV mesh we have, dynamic mesh also included, tool also included, fine. Then from this area we have a dynamic mesh, topo changer, dynamic and tool. I think that many things is required, so let's add up that. Okay, so tool we have, dynamic mesh we have, topo change I don't know either it's required or not. Later on we try to look at, if it is doesn't work, we try to add up that. Okay, now let's try to compile it again. Okay, no such a file or directory. Dynamic fvmesh.h file is it unable to recognize. So let's go back to the src folder. Okay, and dynamic fvmesh. Okay, dynamic fvmesh and dynamic which file? Dynamic fvmesh.h file. Dynamic fvmesh.h file is available. So dynamic fvmesh, if we include ln include, it's supposed to work. Okay, fvmesh dynamic. Okay, yeah, so I supposed to include this here, both is same. Okay, so dynamic fvmesh included, correct. So now just try, it's fixed, that error is vanished. So now lib dynamic wave fvmesh.so is available. Okay, so it's asking for this file. So what I did, I searched locally in the src folder where that file normally in the nearby area from where you copied the template. Try to look at ln include, and normally you will find the similar whatever the file is required in nearby ln include area. Okay, so try to copy from that area, and then we are set with this library. Okay, now so our dependency is resolved with the help of that. Now we want to fix based on our requirements, so just understand what is we have here. Okay, so one things what we look at, we have all the equations in place. Okay, so equation is here. So and you remember that when we look at the FV motions, at that time we also use the diffusivity model concept. Okay, so we try to use the same idea of diffusive model, and diffusivity parameter used to absorb the mesh deformation next to moving boundary by multiplying the calculated functions by a decaying exponential functions. Okay, so we try to add up some decaying exponential function along with this to damp out the or absorb the mesh deformations. Okay, so that is the trick. Okay, so that is I didn't wrote here. So each function we have to multiply it by some decaying exponential function, so e to the power minus alpha z. Okay, where alpha here is something like diffusivity parameter. Okay, and can be selected by user, and we can apply the alpha wherever needed. And z is the vertical coordinate, which is positive z direction, and z equal to 0 correspond to the mean surface elevations. Okay, so we try to, let's look at in something like this way. We have a base plate. Okay, and base plate, now we want to normal to the plate, we want to part up the plate with some sine functions. Okay, for that we are using this different function, so that normal to the plate we consider this as a z coordinate, and along the plate we consider as a x coordinates. That's why I say the horizontal coordinate is x, and the vertical coordinate we try to consider as a z coordinate in this case. Okay, so depending on that we can tune the our particular this solver. Okay, so for that what is required, we try to first go to the H and C file. Okay, so till now we have amplitude, frequency and reference plane. Okay, this is anyway required. So along with that, what is required from this thing, so we require the wave amplitude, definitely we required. What's supposed to be the wave amplitude? Then wavelength we required. Okay, then wave period we required. Then wave direction, in which directions, either positive or negative direction, or 0 for stationary wave. Okay, so how the wave is moving, so we want to define its direction. Okay, so either positive or negative directions we require. Then wave type required, either it is a linear waves, first second order wave, or third order. Okay, so by default we kept linear as a by default. Okay, so 1 for linear, okay, 2 for second order, 3 for third order. Okay, then alpha is the diffusivity parameter to absorb the mesh motion. So this many parameters we required, so that many parameter we supposed to code here. Okay, so right now I'm not deleting anything. First we generate the few new constants. Okay, and after compilation whatever not needed we try to remove. So we try to add up the same thing. So whatever we are adapting, let's say new variables. Okay, so that is what we try to code here, or new data for wave motion. Okay, so we know that whatever we are doing, it is for that wave motions. And new data, first we require the, let's say, amplitude. So we want different name as a wave amplitude. Okay, let's say wave amplitude, or wave, yeah, it's fine, wave amplitude. Or we want then amplitude is here a, it's better we write a complete name. Okay, so it's very easy then. So wave amplitude we required. Okay, so wave amplitude we have. Then we required what? We required the wave length we required. Okay, then we require the period. Okay, so we required wavelength, wave period. Okay, wavelength required, wave period we required. So all that variable we try to define first. Okay, wave length is done, then wave period we required. Okay, then in which direction wave supposed to move, so for that we required something like wave directions. Okay, so wave, either it is positive moving wave or the negative moving wave, or 0 for the stationary. So wave directional we required. Okay, and what type of the wave we want, either linear wave, second order wave, or what type of wave we want. So say type of the wave we required, and the diffusivity parameter is a alpha, that is damping function we want to use. Okay, so that is nothing but the alpha. Okay, so let's say alpha we require. So that many parameters, it is nothing but the amplitude, length, period of time. Okay, directions, so let's say directions, either we have a +1 or -1 or 0, that is the options we have here. Wave type we have a 1 for, let's say, linear, then second for second order. Okay, and last one is the third for third order. Okay, so and this is the nothing but diffusivity parameter. So let's it will try to absorb the what we say, it try to absorb the mesh motions. Okay, so diffusivity parameter we have. Okay, so that many things we want to generate a new variables. Okay, so we are set with the new variables. Now so our new variable is set with this. Now we want to read that new variable also. Okay, so like at present we are reading this amplitude and all this thing. Okay, so in similar line, let's try to read all these parameters what we set. So let me copy first and then we try to modify it here. Okay, so what we want that we supposed to read each and every these parameters. So let's say we try to read the first is this parameter, and here we type as a, let's say, wave amplitude only, length, period, direction, type, and alpha. Okay, then we have a wavelength, so we read the wavelength, then we read the period of it. Okay, then we read its direction, in which directions wave supposed to move, positive, negative, or in 0 means stationary, and what type of the wave we want to generate, either it is a linear wave, first order, or a higher order. Okay, so that is what we want, and the last parameter is the diffusivity as a alpha. Okay, so that is what we needed. So let me delete this part. Fine. So this is all the parameters we set here. New data for wave motion. Okay, so we set with this. Okay, then we want to utilize it. Okay, so before we utilize, let's compile and check either it's we didn't have any new error in it or we have any error. So that is fine, we able to generate this. What else we needed? Okay, reading is over. So now let's look at all. That is fine. So reading not a issue, we successfully read that thing. Here it is giving the informations. Okay, so fine. So here also we can change whatever we needed. Performing dynamic mesh calculations. Okay, so performing dynamic mesh calculations, and then we say the info. We try to take output of all the required values, whatever we needed. Okay, so either of the way, so either we end this here, and then along with that, let's say we try also, if you want, you can have a certain output. So later on we try to fix the output. First let's compile it and run it. Okay, then we try to look at the certain outputs. So performing dynamic mesh calculation for wave motion. Okay, so that is what we gave here. Okay, so then what else we supposed to do? So now we try to remove whatever is not needed in this. So this scaling factor not required at all. Okay, then this scaling factor not required, then this also not required, output anything. Okay, then this stationary points we required. Okay, and this also not required here. Okay, so let's remove this part as well. Okay, so that all the things that is not required, let's delete that part. Okay, and then let's try to replace whatever is needed. So let's have a stationary point here. Okay, so it try to generate the points, and then in between of it we have a certain code. So we how to depending, so we have a 3 wave. Out of that, let's say 1 wave goes as a default wave and other 2 is in the choice. Okay, so if wave type 1 can fix the wave type, so wave type is 1 2 3. Okay, so depending on that wave type, one can try to select the wave. So let's use this and try to generate the code. So if let's say wave type is equal to 2, okay, then we try to have a certain code. Okay, so then we have a certain code here. Okay, so that is over. Then we say that else, and if again if we say wave type is equal to 3, okay, then also we have a certain code. Okay, and else we have a certain code. Okay, so that is how one can quickly look at the coding style. Okay, so that is what we needed. Now we want to fix this code. So let me also go back and open the previous files. Okay, so with which we try to add up the few things. Okay, so what we required within this, we require this new point replace. Okay, and then we try to generate certain vectors within that. Okay, so let's say try to copy this area. Okay, so from the older one, I'm not doing anything else. Okay, so within this, let's say we have a new point options. Okay, fine. Okay. So this is what we have, a new point replace. Okay, now we require the damping functions. So damping functions, what we want that the damping function is okay, first of all we want to generate the wave, okay, in the normal to the our plane. So normal to the our plane is the z directions. Okay, so we say, let's say vector z, that is what we required. Okay, vector z comma whatever the stationary point we generated. Okay, try to utilize that stationary point. Okay, so in the similar line, whatever we have stationary points. Okay, then dot component and the I think let me use the same line here. Okay, so comma, now we require the z component only, so z component. Okay, plus we have to add that particular functions. Okay, so what we going to use, we try to add the functions. Okay, so what we say that now this z component is now added with the help of this particular equation, let's say second. So we want to generate these equations, and before that this equation is multiplied by the absorption functions along with the alpha. So absorption function is what, nothing but the e to the power of something like minus alpha z. Okay, and z is this exponential function. So what we try to do, we try to generate that particular exponential function. So let's say we want to generate this exponential function here first. Okay, and so what required in the exponential functions, I think that is fine. Okay, so in the exponential functions, what we needed alpha. Okay, so alpha star of what we required the that exponential quantity. Okay, so that is the, and that is e to the power of alpha. Okay, so that means we have to generate some exponential functions here. So let's say form. Okay, this is the way one can generate that exponential functions. So this is plus of that exponential functions. Okay, and in the exponential functions we have a minus of e to the power alpha z. Okay, so that is what we want. So minus of e to the power alpha of z. Okay, so I say minus of e to the power alpha star of, we require that z component. Okay, so along with that we require this z component. So let's take this z component here. Okay, and then we try to finish this exponential functions. Okay, so exponential function is done. Okay, so along with that, let me delete all these entries. Okay, so that is not needed. So this is ending here, this is ending here, so this is also not required. Okay, so let me first clean it. This is here, this is here, fine. So what we did, we say vector z, okay, of what we want, stationary vector component z. Okay, so with the help of that we try to modify the z component of the vector, and then say form exponential of alpha into z. Okay, so minus e to the power alpha into z. With the help of that we able to fix this. Okay, so here we able to modified this particular functions. Okay, new replace this thing. Now we try to generate this wave. Okay, so let's generate the wave. So for that, what we want now this. Okay, this particular whatever the functions we generated. Okay, this function is nothing but star of, now is our wave. Okay, so star of, let's say this is the wave here. Okay, fine. So now what is the wave? We have a wave is second order wave we want, then we have amplitude into cos theta. Theta is what? K x omega t. Okay, so cos of that, and above that we have amplitude. So we have first term is what? We have a first term of wave. A is amplitude, so let's use this wave amplitude here. So we have wave amplitude. Okay, wave amplitude star, we have a cos okay, that is the cos functions. Okay, and inside the cos functions, what is needed? We needed cos of theta. Okay, so cos of theta, and theta is nothing but this. So let's try to fix that particular entry. Cos of, let's say, some constant, that is the pi is the constant. Okay, so I have a that syntax, so let's try to use the syntax. Amplitude star of amplitude star of cos of that. Okay, first understand k is nothing but 2 pi by lambda into x. Okay, so 2 pi lambda into x, so it is a big function, so I say this minus of this. Okay. So and then cos is over. So inside the cos we required two entry, this minus of this, and then cos function is over. Okay, so cos of this, that is the first we have. Okay, and inside of this what we required the kx. So kappa x, or k is the angular wave number, equal to k equal to 2 pi lambda, and 2 pi is the set functions or the set constant inside the OpenFOAM. So we can use that constant, and that constant is coming from mathematical constant, and we say 2 pi. Okay, so with the help of that we are set with this 2 pi of these functions. Okay, so that is that functions star of what we required, star of that stationary point component of vector x. So stationary point component of, in case of the z we require the component of vector x, okay, and that is divided by what we have, divided by wavelength. Okay, so divided by is the wavelength. Okay, so that is what we required, wavelength. Okay, so we are set with this one thing. So constant pi, okay, mathematics into star of stationary divided by 2 pi, and everything I think that is fine, minus of what we want, minus of omega into t. Omega is what? 2 pi again by tau. Okay, so same thing we supposed to use again. So here we have a 2 pi. Okay, 2 pi star. Okay, so wavelength we got, correct, and then omega into t. Omega is nothing, 2 pi by tau. Tau is the period. Okay, so 2 pi by tau. Okay, so 2 pi by tau into t, 2 pi by tau into t. Okay, so 2 pi into, let's say first consider time dot its value. Okay, divided by, we have a wave period, we have, so we use that. Okay, so that is what we have here. Then look at the equation. Then we have 0.5 of Ka into cos 2 theta. Okay, so Ka into cos 2 theta, so 0.5 of Ka into plus of it. Okay, so plus of this, so this is one term we set, then plus of another term we have. So what is there in the term? We have a 0.5, okay, 0.5 star of, we have a this A is wave amplitude, 0.5 of Ka. Okay, so A is wave amplitude, so let's say 0.5 of this wave amplitude. Okay, star of K. K is nothing but this 2 pi into stationary component. Okay, K is what? K is 2 pi by lambda, 2 pi by lambda. Okay, so let me take this, control C, V, here stationary, this not required, so 2 pi by lambda, that is K. Okay, so we have a 0.5 Ka star of, now star of what we required? We required cos of what? Cos of 2 theta. So whatever we have here, 2 times of this value. Okay, so this, and here I say 2 star of this value. Okay, so 2 cos theta of this value. So this is done, this is done, this is here, fine. So this is, we are set, I think, with the first function. Okay, so let's try to compile and check either we have any error or not. So we are breaking with some of the let's say some of the, yeah, that is correct, it is missed, is this way, fine, here, that is correct. 2 pi is not a member. Okay, so 2 pi is so in the new style saying not a member, I think P supposed to be capital, same to me, P supposed to be capital, correct, then it is a member of this 2 pi. Fine, so we are set with this. So we says that this is the first one, wave type equal to 2. Okay, now second type is what? We have everything 0.5 of cos 2 theta plus of this few entry we required. So let's copy whatever we have at a second level, control C, paste it here, control V. Okay, so this is the second term along with the second term, we said third term now we want. So that is the our third term. First term same, second term same. Now we require the third term. So third term is what? 3 by of 8. Okay, so that is the third term. So let's use this. Okay, so third term is nothing but what we required. We required 3 by 8. So let's say third term is 3.0 by 8.0. by 8. Okay, so let me particularly clear. Star of what we want Ka to the power 2. Okay, so whatever we generated Ka power of this, so let's have a star power of this one, power of what we want as a power. So power of that functions. Okay, so power of this entire thing, power of 2 of that particular function. Okay, or let it be 2 here only, so no confusion at all. Okay, so that is what we have. So power of Ka, then cos 3 theta, that's it, into star cos 3 theta into star of, in case of 2 we require the 3 theta. So here over this cos functions is missing. This cos functions is missing, so let's have this thing here. Fine, so I think this is also set. Okay, let's see. And the last one is by default. Okay, so this is else. What we required here, we require very simple thing, a cos theta, a cos theta. So first term from the that one only, nothing else. Okay, so let me first copy this one, everything to here. Okay, so from here till here let me copy, then we modified. Okay, so for this what is required? Required a cos theta, not the other any term. So let me delete this term to here. This is still here, this is here, a cos theta, this is this. I think we are set with this. Okay, so one thing maybe I missed is about the directions of the wave. Okay, either it is positively running wave or negatively running wave. Okay, so we have to be careful about that part. Okay, so anyway, idea is that how to fetch a library. So this is how one can construct this particular library. Okay, so depending on your requirement you can develop this. Okay, so here I commented this part, let me comment this as well. Okay, so along with that, in the h file also now we are no more using, so let me comment this also. Okay, and then let's try to compile it and check either anything is failing. So we are set with this library creations. Okay, so that's how one can generate very easily, not easily, but if you have an understanding how to fetch the particular template and how to modify it, one can quickly fix whatever is needed. Okay, so only one thing I didn't incorporate at present is that either right running wave or the left running positive or negative wave is part is missing, otherwise everything is coded inside here. Okay, so that is the way one can use, and when we want to use this, we supposed to use dynamic wave FE motions. In case of the dynamic inkjet FE motion, FE mesh, we try to use this, and accordingly one can run the case.